proceed dengan kelas kita berkaitan dengan magnetic field, transformer and motor. Okay. So saya akan present slide. Okay. A window. Okay. Okay, so for the magnetic field, first there are three type of magnetic field. Okay, yang the first one is magnetic field around a long straight wire. Okay, so basically the right hand rule. Okay, you can imagine using your right hand rule. Okay, consider that you have this marker. Okay, this marker. Okay, and then this marker is a conductor. And then a current is flowing through this conductor. And then you can imagine that the magnetic field is produced around this. When a current is flowing around this conductor, it will produce a magnetic field. Okay, in circular motion. Okay, kalau semua boleh nampak circular motion. Okay, circular motion, and then your thumb will be the current. Okay, and then you can calculate the magnetic field B. Okay, using this formula. B is equal to mu naught equal multiply with current I divided by 2 pi R. Okay, and then R is the position at where you want to calculate the magnetic field. Okay, let's say you need to measure the magnetic field somewhere over here, so the R will be from here to R. Okay, and then the second type of the magnetic field is okay, the second type of magnetic field is, wait a moment, I change to the SketchUp. Okay. Okay, the second type will be, okay, consider, okay, a conductor. Okay, and then you coil, okay, you coil with a wire. Okay, you coil with a wire. Okay, you coil it with a wire. Okay, and then you let the current flow. So here you imagine that the coil is your current. So the magnetic field that will produce will be, okay, nampak tangan saya? Okay, the magnetic field will be produced at your thumb. Okay, so it will be ni. Okay, this will be your magnetic field. Okay. Okay. Okay, sorry for my bad drawing. Okay, then this is the second type of magnetism. Okay, electromagnetism punya forces electromagnetic field. Okay. Okay, and then you are going to use this knowledge in order to relate with the transformer. Okay, in a transformer. Okay, let me present. Okay, in a transformer, it is basically an AC device, which is a alternating current device used to change high voltage low current and into low voltage high current AC, and vice versa, meaning that you can change from the high voltage to low voltage, and then from low voltage to the higher voltage. In brief, it transfers the electric power from one circuit to another. Okay, it consists of two circuits. It does so without change of frequency, and then it accomplish this by electromagnetic induction, which means that it using the induced current, where the two electric circuit are in mutual inductive influence of each other. Okay, maksudnya both of the circuit is connected to each other. Okay, and then okay, transformer. Okay, basically transformer coil is isolated, and then the AC power transmission, there are two type of transmission, which is step up transformer. It change the voltage from low voltage to the high voltage, and then step down transformer, which is changes occur when you need to reduce the voltage, convert the high voltage to the low voltage. Okay, and then this is the transformer behavior based on Faraday law. Okay, basically the epsilon is the electromotive forces, so and then n is number of wire, and then theta b is the magnetic flux. Okay, if you can see, this is the transformer diagram. You can see that the main thing you must know that it use alternating current. Okay, alternating current type. And then it consists of two circuit, which is circuit at the primary. Okay, primary NP, VP, and then second circuit will be the secondary and secondary. Okay, secondary, and this is the number of coil. Okay, if you need to use a step down transformer, then primary coil at the circuit must be higher than the coil at the secondary coil. Okay, vice versa. If you need to use a higher, then the primary must be less coil, and then the second circuit will be the higher coil. Okay, and then as the current flow towards the coil, okay, it will apply the magnetism law, okay, magnetism concept, okay, principle. Once the current flowing at the coil, and it will produce a magnetic flux, okay. This magnetic flux will convert all the power, okay, and then voltage, okay. Okay, this is the working of a transformer. Okay, when current is the primary coil, changes being alternating in nature, a changing in magnetic field is produced. Okay. Okay, the reason why transformer use alternating current because you cannot move the core. Okay, if there are no movement, then there will be no magnetic field that will be produced. So that's why transformer using alternating current so that it can goes in both direction, which is okay, it can go both direction, meaning that it can go upward, it can downward. Okay, so the changes in the movement will generate a magnetic field, which is will be used to convert the energy lah, okay, energy or voltage or it can be current. Okay. Point number 2, this changing magnetic field gets associated with the secondary through the soft iron core. Okay. Transformer ni dia it have its own core. Hence magnetic flux link with the secondary coil changes, which induce electromagnetic force in the secondary. Okay. Okay, this is the diagram for the transformer model. Okay. Ideal transformer only exists in the book, but in the real world, there is no such thing as ideal transformer. Ideal transformer have 100% of efficiency, okay, but it is mostly it is not in the real world. There's no such thing as ideal. Okay, this I already explained previously, which is NP is the number of winding, okay, and then circuit, okay, and then number of winding on the number of wind, and S is the number of winding on the secondary, and then IS is the current output from the secondary, and then voltage source V secondary is the voltage across the secondary circuit. Okay. Okay. This is the formula that you are going to use in order to determine either voltage or number of coil or the current. And then this will be equal to the number of turn ratio, which is A. Okay. Okay. Consider the first. I would like to give you one example. Okay, you can try this together with me. Sekejap. Okay. Uh, Hmm. Hmm. Okay, this is the circuit, eh? Okay. Okay, figure 4, okay, meaning that this figure shows a circuit with an ideal transformer connected to a 470 volt power source at the primary and a resistor R, okay, of 70 ohm at the secondary. Okay, R is equal to 70 ohm. Okay, the number of turn in the primary N1 and secondary N2 are 25 and 5. Okay, this is 25, and then the second one is 5. Okay, and then the first question is to determine the voltage at the secondary coil. Okay, now first we need to write the equation. We have Vp over Vs equal to Np over Ns equal to Is over Ip. Okay. Now determine the voltage at the secondary coil. Okay, now we have 470 volt at the primary. Okay, sekejap saya ada orang baru nak masuk dalam group dalam kelas, so saya kena approve. Okay, and then we need to determine the voltage at the secondary coil. Okay, and then we know that the number of turn at the primary is 25. Okay, 25 25 over, okay, number at the secondary is 5. Okay, so now what we need to do is to rearrange in order to calculate the voltage at the secondary. Okay, 470 times with 5 is 2350, and then 25 Vs. So Vs is equal to 2350 over with 25 equal to 94 volt. 94 volt. Okay. And then from the question, you also need to determine the value of the current through the primary and secondary when the switch is open and closed. Okay, there will be two types, which is open and closed. Okay, open and close. Okay, what is the difference between open and closed circuit? Okay, open means that the current cannot flow through resistor 70 ohm. Meanwhile, if the switch is closed, then the current can flow through resistance 70 ohm. Okay, meaning that in the open circuit, the current in the primary circuit will be 0. Okay. is primary. And then secondary is also will be 0. Why? Because the switch is not connected. So that's why it will be both 0. Okay. If the switch is closed, okay, then we can calculate using V. Okay, for the close, when the circuit is closed, we can calculate the current at the secondary. Okay, current flowing at the secondary will be, okay, we already have the voltage value now. So, and then we have resistor R. Okay, so you can directly apply voltage is equal to IR. Voltage is 94, and then current is, you need to measure, you need to calculate, and then R is 70 ohm. Okay, so IS is equal to 94 divided by 70. 94 divided by 70, you will get 1.343 ampere. Okay. And then for the primary circuit, now you apply the formula, okay, which is you get it, which is the transformer, ideal transformer formula. Okay, you have voltage at the primary, which is 470, divided by voltage source 2, which is 94. Okay, and then equal to I secondary. Okay, I secondary is, you already determined previously, which is equal to 1.343. So IP will be I at primary equal to 0.2686 ampere. Okay, 0.269 pun betul Farah? Okay, so the current at the primary is 0.2686 ampere. Okay. Okay, now I hope that you can understand. Based on this calculation, I hope you can further understand the principle of transformer. Okay. Okay, now I proceed to the lecture. Okay. However, in a real world situation, okay, a transformer will have few types of losses. The first one, the losses from the material itself, which is the copper losses. Okay, copper losses, it will produce a resistance for the flow of the current. Okay, so this is the copper losses, okay, which is denoted as RP. And then the leakage flux losses. Leakage flux losses ni is based on the material itself of the transformer. Okay, and then the core losses, which is eddy current and hysteresis losses. Okay, for core losses ni, okay, let me draw something. Okay. Kejap Kejap now. Okay. Okay, eddy current losses. Eddy current, okay, eddy current is produced when the magnetic field, okay, when the magnetic field occur, okay, okay, this is the electromagnetic field, okay, then there will be another current that is somehow produced around the electromagnetic field. Okay, this current is known as eddy current. Okay, this eddy current is considered as losses. Okay, so this is the electromagnetic field. Okay, okay, this consider the transformer magnetic field. Okay, and then it will also produce eddy current. Okay, eddy current. Okay. Okay, this eddy current is considered as the losses. Okay, in an ideal transformer, it only have the current that flow inside the transformer core. Okay, so that is the three types of losses for transformer. Okay. Okay, now we proceed to generator and motor. Okay, in the beginning of the lecture, I already mentioned to all of you there are three types of magnetism. Okay, the first the first two magnetism you can determine using your right hand rule. But for the second type of magnetism, you are going to use the left hand rule. Okay. For electric motor, it change the energy from the electrical energy to the mechanical energy. So this is the electrical power input, and then it will produce a mechanical output. Okay, based on the rotation. Okay, and then for electric generator, it convert the energy from the mechanical, okay, to the electrical energy. Okay. 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 When a current carrying conductor is placed in a magnetic field, there is an interaction between the magnetic field produced by the current and the permanent field, which lead to a force being experienced by the conductor. Okay. 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 The magnitude of the force on the conductor depends on the magnitude of the current which it carries. The force is maximum when the current flows perpendicular to the field as shown in the diagram. Okay. Ini saya akan explain sekejap lagi. Okay. Jadi bila saya explain ni lagi senang untuk kamu faham. Okay, this is the left hand Fleming rule. Okay, basically the forefinger is the magnetic field, and then the second finger is the current flow, and then thumb is the thrust. Okay. Okay, consider there's a magnet which is north and south, and then this is a commutator, and then it rotates with coil. Commutator ni dia akan rotate with coil. Okay. And then as the commutator rotate, it will membelah. It will membelah the electromagnetic field. Okay. And then once the magnetic field tu terbelah, dia akan menghasilkan forces. Okay. In this case, okay, the base will be from north to south. Okay, this is the forefinger. And then you can determine the current rotation using the left hand rule. Okay. Once commutator rotate, it will produce the electromagnetic field lah. Okay, and then this electromagnetic field will be the energy lah. Okay, energy that you can measure. Okay, energy will be its power lah. The power of the motor atau generator. Okay, boleh This is the base north to south. Okay, and then force pointing downward, and then this will be the current flow. Okay. Okay. The highest power, okay, the highest energy will be when the commutator is perpendicular. Okay, this is perpendicular. Okay. Okay, an electromagnet is the basis of an electric motor. An electric motor is all about magnet and magnetism. Okay, a motor uses magnet to create motion. Okay. Opposite attract and likes repel inside an electric motor. These attracting and repelling forces create a rotational motion. Okay, rotational motion by the commutator. Okay. Okay, this is the basic part of the electric motor. Okay, it must have a armature. Okay, armature, and then commutator in order to rotate. Okay, armature is simply the current flow current flow of the coil. Okay. And then brushes. Okay, brushes ni tujuan dia untuk pergerakan tu jadi lebih smooth. Okay, and then of course you need the permanent magnet in order to produce an electric magnetic field. Okay, as the armature rotated, then it will disrupt the magnetism of the magnet base tu, and then it will produce a electromagnetic current lah. Okay, so finally it will produce an energy in terms of power. Okay. Okay, ni function of commutator to keep the torque on a DC motor from reversing. Okay, commutator only using a DC current, and it only can rotate either you set it clockwise or anti-clockwise. It's not like transformer. Okay, if you are using AC, then the commutator will flow. It will disrupted. Okay, maksudnya dia boleh dia akan jadi forward, dia akan jadi reverse, forward reverse. Okay, tapi kita tak nak macam tu. Kita hanya nak dia pusing in either clockwise or anti-clockwise. Okay, and then the coil move through the plane perpendicular to the magnetic field. Okay, which is magnetic field. Okay, flow from the north to south, and then commutator will rotate, and at perpendicular condition will produce the highest power. Okay, and then the contact of the commutator are attached to the axle of the electromagnet, so they spin with the magnet. Okay, so itulah tujuan dia, untuk spinkan magnet tu. The brushes are just two pieces of springy metal or carbon that make contact with the contact of the commutator. Lah. Okay, tengok, since the current is DC, so that's why it only rotate in one direction. Okay, and then it must be connected to the battery. Okay. If you did not connect to the battery, then it cannot spin lah. Okay. Previously, the most basic motor only have one. This is armature, only one armature. Okay, armature. But in order for you to increase the efficiency, you can attach lot more armature. Okay, so that it can keep on disrupt the magnetic field, so that it will produce a higher power. Okay. Okay. This is the characteristic of the motor. Basically, the torque is inversely proportional to the rotational speed. Okay. The meaning of the inversely proportional, okay, you cannot have both parameter. Okay, you cannot have both parameter working in the maximum condition. Either one must be less than, and the other one will be higher than. Okay, for example, in okay, if you look at this graph, okay, when the speed is 0, the torque of the motor is high. Okay, on the other hand, if the speed of the motor is maximum, and then the torque will be 0. Okay, that is what means by the inversely proportional lah. Okay. So note that torque is inversely proportional, or in other words, it is a trade-off. Okay. And then the stall torque represent the point on the graph at which the torque is maximum, but the shaft is not rotating. Okay. And then the no load speed is the maximum output speed of the motor when no torque is applied to the output shaft. Okay. So dekat sini lah. Sini when the omega, which is rotational speed, is the maximum, and then when the torque is the highest, there will be no speed. Okay. So this is the characteristic. Okay, if you operate the motor at the low rotational speed, then you will have this kind of this characteristic of power. Okay. Meanwhile, okay, if you operate at a higher speed, then you will have a low power. Okay. So in order to find the best trade-off, okay, it is assumed that 0.5 torque with 0.5 rotational speed will produce the highest maximum power. Okay, and then this is the characteristic of the power produced by the particular motor. Okay. Okay. So this is the losses for the motor. For the electrical, the copper losses in various winding, okay, such as the armature winding and different field winding. And then the magnetic, okay, these are the iron losses. Okay, iron losses meaning the material itself has resistance. So that's why it resistant as well. And then stray load, these are the other load losses which is not covered above. Okay. Then okay, this is the efficiency of the motor, mechanical over the electrical power times the 100%. Okay. Okay, and then this is the power output, which is P output will be torque times with omega. Okay. And then the omega must be in radian per second. Okay. Okay, I would like to add another formula. Okay. Another formula for you to little further understand. Okay. Okay. Power is basically equal to 5,250. Okay. Times with time with okay torque and angular speed omega. Okay, so when the angular speed is high, then the torque must be lower. And then it works vice versa. Okay, vice versa. meaning that if the top is lower, then the omega will be increased. Okay. Okay, this is just a formula for the motor. Okay, basically this is the end of the lecture. Okay, perhaps you want to ask me anything. I open for the Q&A session. Fahmi Osman, sedap makan? Okay, ada apa-apa soalan? Ada yang nak bertanya mengenai midterm pun boleh
W tu apa sir?
W tu rotational speed. Kan tadi saya explain tadi rotational speed. Dia bukan W sebenarnya, dia omega. Okay, T is top lah. Okay, kelas ada 42 orang jadi saya akan upload video lecture ni ke dalam YouTube sebab nak make sure semua orang dapat akses kepada lecture saya. Lecture saya yang kapasitor dan inductor saya tak masukkan sebab saya dah upload yang sebelum ni sama je content dia. Kalau saya tunjuk cara jawab soalan lecture yang lepas, yang mana okay select sini hujan lebat. Okay, tak apa. Boleh nak tanya apa Farah? Kalau ada soalan lagi senang saya cuba buat Farah, boleh tanya saya kalau ada apa-apa soalan mengenai kapasitor dengan inductance. Okay. Kita tunggu Farah sekejap Farah ada nak tanya soalan. Sementara tu kalau ada student lain yang rasa dia tak faham bahagian transformer atau magnetic field boleh tanya Ada lagi ke yang belum submit lab? Okay. Kalau ada yang belum tu, saya mohon supaya submit Okay. Okay. Sebenarnya saya dah paling lenient dah dengan semua student-student saya. Maksudnya saya just minta awak supaya submit je. Okay. Walaupun saya kata saya nak awak hantar pada hari Jumaat, tapi saya buka dia punya assignment port tu lebih pada hari Jumaat. Sebab apa? Sebab saya nak make sure yang kamu semua submit dapat submit. Dan yelah, saya pun faham mungkin ada yang internet tak berapa laju. Okay. So saya masih bagi peluang lagi Okay. Sekejap saya buka Oh, okay. Terbaik. Bagus juga soalan circuit ni Jadi Farah tak boleh jawab dua soalan circuit Okay, sekarang ni kita tutup dulu. Kita okay. Ada yang Zul Ikram laju kipas Zul Ikram Oh, sini hujan lebat Okay. Jadi Farah tak dapat jawab dua soalan ni Okay. Jadi saya akan buat yang 3.24. Nampak ke semua? Okay, saya harap semua nampak Untuk soalan ni, first kali saya akan bahagikan ini kepada 3 node Node A, B dan C. Okay. Seperti yang saya selalu bagi lecture, kita assume current ni seolah-olah seperti air yang mengalir di dalam sungai. Jadi apabila air itu mengalir, dia akan melalui batu, dan resistance yang lain lah. Jadi batu ni kita assume dia sebagai resistance. Dan selain daripada tu, sungai ni dia ada banyak cabang Cabang ni pergi ke jeram ni, cabang B pergi ke jeram B, cabang C pergi ke jeram C. Jadi itulah. Jadi basically kita boleh gunakan konsep tu untuk kita determine the equivalent capacitance Okay. In this case, untuk node A, first kali node A this is node A. And then from node A to node B, there will be one capacitance capacitance known as 12 microfarad Okay, and then arrive to B. Then untuk pergi ke node C, there will be ada dua junction. Okay, satu junction ikut bawah ni. Okay, and then there another junction. Okay, saya tukar warna Okay, this is the first junction and then this is the second junction. Okay, now first look, we draw for the straight junction Okay, for the straight junction, okay, B to C. Okay, B to C, there will be two capacitor. And okay, walaupun dalam soalan ni dia tunjuk dua, dia ada corner sikit, tapi sebenarnya dia tak ada node. Okay, jadi bila tak ada node ni, dia straight je lah. Okay, jadi di sini dia ada 4 microfarad. Okay. And then satu lagi satu lagi which is 4 microfarad juga Okay. So basically dah sampai dah dekat junction C. Okay, junction C. Okay. So ni junction C ni. Okay, dah ni kira cabang sungai dekat C. Okay. Okay, and then kita ada B to C. Okay, B to C ni adalah node yang berbeza B to C. Okay. A to B. Okay, then ada A to C. Okay, kita apa? Kita buat B to C B to C dia adalah parallel Okay. Sebab dia adalah cabang yang berbeza. Okay. Kita boleh pegang konsep lebih kurang macam tu lah. Tapi dalam bahasa elektrik ni dia adalah node yang berbeza lah. Okay, and then kita ada lagi satu node yang tak yang berbeza which is C to A. Okay, C to A. Okay, so dia ada satu lagi kat atas ni. Okay. Okay. And then C to A adalah 5 microfarad. And then sekejap tadi B to C 2 microfarad 2 microfarad. Okay, so 4 microfarad and then this one also 4 microfarad okay, dia dah saya dah tulis dah. Okay. For capacitor series, okay, for capacitor it is opposite to the resistance So 4 times 4 okay, saya tulis betul-betul lah 4 microfarad parallel with 4 microfarad which mean 4 times 4 divided by 4 plus 4. Okay, berapa farad 2. Okay. Okay, ini kita tulis dia 2 microfarad Okay. Jangan buang micro ni. Okay. And then okay, sekarang ni 2 microfarad is parallel with 2 microfarad which is okay, yang ni okay. So 2 kali dengan 2 over 2 tambah 2. Okay. Berapa Farah? 1. 1 microfarad. Farah marah dengan saya ke Farah? Okay, 1 microfarad Okay, jadi sekarang 1 microfarad adalah series dengan 12 microfarad Okay. So, series dia akan jadi silap, sorry, sekejap. Okay, 2 dengan 2. Sekejap. Okay, 4 dan 4 dia series. Okay, 2 dengan 2 ni dia series, dia parallel So, dia akan jadi 2 microfarad parallel with 2 microfarad So, 2 plus 2 equal to 4 microfarad. Okay. So, now 4 microfarad is series with 12 microfarad. So, 4 times 12 berapa Farah? Yang lain pun boleh cuba buat 3. Okay, 3 So, 3 microfarad. Okay, so sekarang ni kita dah selesaikan bahagian yang ni Okay. So, sekarang tinggal bila dia parallel, kita just directly tambah 3 tambah 5 equal to 8 microfarad. Okay. So, dapat ke 8 microfarad? Sekejap, ni 4 microfarad. Okay, ni 4 ni, okay. Series with 4 okay, alright. Okay, so sekarang ni, kita cuba buat yang ni Okay, ni kita buat sama juga. Find the equivalent capacitance for each of the circuit. Okay, yang ni kita ambil dia A, B, C, D. X dengan Y ni dia saja ni. Okay. First sekali kita draw a straight line. Mula dengan A. Okay, A A. Okay, A ke B. A ke B adalah 16 Okay, and then B ke D. Okay, B ke D adalah 4 microfarad Okay. Okay, and then dia ada satu lagi. Okay. Okay, 4 microfarad and then atas dia 5 microfarad. Okay, B ke D. And then D to C. Okay, D to C kita biar Okay, and then dia ada C to A. Okay, C to A. So maksudnya dia ada satu lagi kat atas ni. Okay, C to A dia ada 6 microfarad dengan 3 microfarad. Okay, so macam biasa kita selesaikan 5 dengan 4 dulu 5 dengan 4 dia akan jadi 9 9 microfarad. So then 9 dengan 16 9 dengan 16 dia series. So equal to berapa? Okay, 18. So A ke B tu 18. Okay, A ke B A ke B 18. Okay, okay. 18. Tak apalah, kamu assume lah ada 16 Assume dia 16 Okay, okay, tak apa. Kita ambil dia 18. 18. 18 Jadi 9 kalikan dengan 18 divided with 9 plus 18. Berapa? Fahmi Osman? Cik parah je. Adam Fahmi 6. Okay. Terbaik Adam Fahmi Okay, jadi sekarang ni tinggal yang ni dan 3 microfarad dan 6 microfarad ni Jadi 3 dengan 6 ni dia adalah series So 3 kalikan dengan 6 bahagi 3 tambah 6. Dapat berapa? Banyak biskut raya tu. 6 kak Adam Fahmi tinggal dapat 2 Okay, dapat 2 Okay, so sekarang ni 6 adalah parallel with 2. Okay, so you will get parallel Parallel 6 plus 2 equal to 8 microfarad. Okay 8 microfarad. Okay. So 8 microfarad. Okay, ada apa-apa soalan lagi ke nak tanya? Ingat kapasitor. Kapasitor I equal to C dV over dt. Kemudian V equal to L di over dt. Okay. Then integration of I equal to C integration of dV over dt. So bring dt to the left hand side. So C dV I dt. So and then V 1 over C integration C bawa ke right hand side. Kita akan dapat I dt plus V T naught Okay. Ni integration Then untuk L di over dt okay. Integration of V equal to L integration of Okay. Kita bawa terus dt ke atas senang. dt equal to L integration with di So integration of current equal to L bawa to left hand side. Okay. So dia akan jadi 1 over L integration of V T plus I T naught Okay. Jadi Okay, ada apa-apa soalan lagi? Okay. Nilai yang mana
Sir,
Yes.
yang A ke C tu bukan dia ada 3 ke nilai?
Ada 3. Ada 3
6 ohm
6 oh 6 3 6 3
6 3 dan 3.
Okay. 3 3 6 okay So kat mana kita nak letak 3 ni? Okay, sini C to A. Then CA. Okay, basically dia ada satu lagi kat sini. Okay. So sini akan jadi 3 microfarad. Okay. A to B 18. Kemudian B to D. Okay, dia ada 4 dan dia ada 5. Okay. And then D to C. D to C tak ada Tapi dia ada C to A. Okay, so C to A ada 3 dan 3 campur 6. Okay. Okay. Okay So untuk yang ni kamu selesaikanlah dulu. 3 dengan 6. Kemudian 5 dengan 4. And then last sekali ada 3 lah parallel. Yang ni dan yang A to D ni. Okay Ada apa-apa lagi nak tanya? Bawah apa Akil Najmi? Okay, Syahrul Izam ada nak tanya apa soalan? Saya buka kepada soalan. Okay. 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 So, saya rasa setakat tu je kelas kita hari ni. Kita jumpa lagi minggu depan. Kemudian, kamu semua kena jaga diri Dan jangan lupa study. Seronok cuti Duduk belajar kat rumah. Macam mana feeling belajar kat rumah? Lecture semua online? Oh, okay. Tak ada feel Itulah saya faham sebab tak semua orang boleh akses internet yang baik Itulah apa-apa pun kena hadap benda ni Kita semua kena hadap benda ni. Okay. Itulah. Sebenarnya saya pun risau sebab masing-masing lecture tak datang. Okay. Patutnya kelas saya ni ada 50 lebih orang. Tapi dalam 10 orang tak boleh nak akses internet masa saya mengajar. Jadi benda-benda ni memang sedikit sebanyak tak berapa elok lah. Okay. Jadi saya akan upload juga lecture ni dalam YouTube Jadi kamu semua boleh akses Okay. Okay, Zul Ikram Jupirin Sebenarnya bukan fakulti, universiti tak buat decision lagi. Okay. untuk makluman kamu semua, final ni final elektrik adalah pada 22 hari bulan 12 hari bulan 8 tak silap saya. Kalau saya tak silap 12 bulan 8. Kalau kita ikutkan kita ada lagi kurang lebih kurang untuk SEM ni habis lebih kurang dalam 4 minggu lagi Tapi kalau untuk final tu mungkin ada 6 minggu lah. 6 ke 7 minggu. Jadi setakat ni universiti masih lagi belum membuat apa-apa keputusan untuk final tu sama ada online ke ataupun dari face to face Akhil Najmi suruh dia buat online. Siapalah saya nak suruh-suruh saya ni cuma membantu operasi sahaja. Itulah sebenarnya ada pengumuman yang akan dibuat lah dalam masa terdekat ni. Tunggu majlis fakulti Itulah. Tak boleh buat macam mana lah. Kena tunggu pengurusan lah apa dia punya result. Saya rasa setakat tu saya sudahi kelas saya ni dengan surah Wal-As dan kita jumpa lagi minggu depan Assalamualaikum dan terima kasih.